In this video, we're going to be finding the area of a composite shape. This shape is different than the last four examples. If you look at this picture, we're only going to be finding the area of the shaded region. It's similar to the last examples because we're still going to divide this in our minds into two different shapes, a circle and a triangle. But instead of adding the area of the triangle and the area of the circle together, this is actually going to be a subtraction problem. We're going to take the area of the circle and then subtract from it the area of the triangle. I want you to picture poking a pair of scissors right here at the corner through the triangle vertex, and then I want you to picture cutting along this base, then cutting along this slant height, and then cutting along this slant height until you can peel away that triangle and wad it up and throw it in a trash can. And then I want you to picture that since you've taken away that triangle, there's a big hole here in the shape of this triangle, and you'll be able to see right through the circle. And all that will be left is this edge of the circle that has been shaded. These three sections will be left over. First, let's start by finding the area of the triangle. The formula for the area of a triangle is area equals base times height divided by 2. Let's take a look at the base. They don't give us the full value for the base, so what we're going to have to do is deduce what the base actually is from the information we're given. So the left side of this is equal to 12 feet. The right side of this is also equal to 12 feet. So 12 and 12, we get a base of 24 feet. Next, we need to find the height. And the height is the line segment that is perpendicular to the base. So I'm highlighting this 90-degree angle because perpendicular means at a 90-degree angle. And this line segment is perpendicular or at a 90-degree angle to that base of 24 feet. And this length measures from the top of the triangle to the bottom of the triangle. You can see this measurement is labeled as 23 feet long. So the height of the triangle is 23 feet. Now I'm going to type into a calculator 24 times 23, and we get a total of 552. That goes in the numerator. And then we can't forget to divide by 2. And when you divide by 2, you get 276 square feet. So we found the area of the triangle. Now we're going to find the area of the circle. Area is equal to pi r squared. We're going to replace the variable r for a number. When you replace a variable with a number, that is called substitution. So let's see what number we are able to substitute for r. What is r equal to? Well, r represents the radius, and the radius extends from the center of the circle to the edge of the circle. And the label that is on the line segment from the center of the circle to the edge of the circle, or I should say on this ray, is 13 feet. So the radius is 13 feet long. Next, I'm going to record pi times 13 times 13 because a power of 2 tells you how many times to record the base. So I was supposed to record the base twice, that 13 two times. 13 times 13 gives you 169. Now I'm going to use my calculator and type in pi times 169, and that gives me 530.9291585, etc. And I rounded to the nearest thousandths place, so I didn't have to keep writing all of those decimal places. From here, what I'm going to do is I'm going to actually, in the table, fill in the area of the circle first. So type of shape, I'll write circle. And then we found the area of the circle to be 530.929 square feet. Then I will record the area of a triangle. We found the area of the triangle to be 276 feet. I'm going to line it up as if I was going to do this without a calculator so that you remember that when you're adding and subtracting with decimals, you have to line up the decimals. That's why I had to add 3 zeros. So we take the area of the circle, and remember I told you this problem is different than the last 4 problems. We have to subtract the area of the triangle. Remember, we're taking away the area of the triangle, so we're just left with the shaded region. We're just finding the area of this shaded region. That's why we have to take away the triangle. So it's 530.929 minus 276, and we get an area of 254.929, which I'm going to round to the nearest tenth, just like I'm asking you to do in the Go formative. So the area of just the shaded region is 254.9 square feet.